Hello. Yeah, it's always fun to be back, right? So today we'll be doing something a bit deep. Yeah, still within the line of cloud security, cloud architecture, and the cloud build. Serverless by way to say follow up from what we probably put out the last recording. And what we're doing today is to create serverless APIs that create, read, update, and delete items from a DynamoDB database. So if you're wondering, serverless, why this whole push about serverless for recordings recently? I've been doing quite a lot around serverless environments, and I thought it's actually a cool technology to showcase on my YouTube channel, which is obviously why I'm actually recording these videos, just to show you how you can easily take that classical conventional on-prem mentality and start shifting towards the containerization, microservices, where serverless actually shines. And the whole concept of serverless is we just want to be concerned about the application, the programming, and all that stuff, not about the underlying servers that manage or that it runs on. Nobody want to start thinking about all that headache now within the dev world. Hence, bringing speed, efficiency, accuracy, and also scalability really high. All right, so enough with my chitty chatting as usual. So let's see what comes next. Now, the requirement for this, you need to have a basic understanding of AWS Lambda, AWS DynamoDB, the AWS console. Obviously, you should, I believe. Then the basic understanding of serverless architecture, then the basic knowledge of the API gateway. Some of the resources I'll be using here were collected from AWS archive. So obviously, I do not take ownership of them. I'm just using them as content to be able to share knowledge or deliver knowledge. All right, the introduction. In today's session, you will create a serverless API that creates, read, updates, and delete items from a DynamoDB table. So it means we have to create a DynamoDB. Then we'll also need to look at using the API integration platform which AWS have over on the platform. Now, DynamoDB is a fully managed NoSQL, so the conventional SQL query language database, which we know like MySQL and the other likes, which uses tables and structures, schema. We are seeing DynamoDB coming in here to shine, hence improving speed and efficiency as a NoSQL database service, which provides fast and predictable performance with seamless scalability. These are some of the strengths of DynamoDB. The steps which we'll be covering today will be to create a DynamoDB table and a Lambda function. Then we'll create HTTP APIs. Although you have REST, you have also sockets, WebSockets. Okay, so we'll also be creating routes and integrations. Then we'll be attaching integrations and routes, integrations to routes. Then also that all the way to the API manager we should be looking at. Then also we will test and validate the API by making some calls using call. I'm working on a Windows environment today, so again, this is just for testing. All right, so the workflow will be to once we're done building, this is how it's going to operate. You invoke HTTP API. The API gateway routes the request to your Lambda function, which triggers the function based on the event. Then the Lambda function interacts with the DynamoDB and returns response to the API gateway. Now, we covered the API gateway in our last recording. You really want to go look at that stuff. It's quite like a powerhouse, a power engine. Then the API gateway then returns the response back to you. So which means the user or the client will not have one-way access to the DynamoDB. Then that's actually bad practice. So we see the HTTP API having to do that relay, then the Lambda function having the direct communication with the DynamoDB. Once an event is triggered, actions are carried out on the DynamoDB, then returned. Now we can set a bit of filtering or exclusively filtering content here at the Lambda function, sorry, at the API gateway level, which we're going to look at basically. That's not included in this architecture. Okay, so that should be all for the chitty chats, and moving on. I think I'm stuck. Okay, so let's get on with the first part of the task, which will be to create a DynamoDB table. I'm going to go over to my AWS console, which this is what it looks like. Then I'll look for the DynamoDB. I think this is DynamoDB. All I have to do is just click on create table. Now I'll have to give the table a name. Obviously, we need to give it a name, then also set key ID, a couple of those stuff. So let's just call this maybe a random name, HTTP. I'll just use the name, maybe create, read, use, delete. All right, that sounds like a good name. Items. Okay, then the partition key. Remember, if you're not familiar with DynamoDB, I'll recommend you go look up a bit of tutorial understanding what it is and how it works. A key, a value, kind of matching. So the partition key here will give it ID. Then we'll leave it as a string. So we can actually make these binary numbers or whatever, but I'll just leave it as string. Then we can also set a sort key if we want. Again, these are attributes that can be used to uniquely identify data on your table. So, but I'm just going to leave only the ID, pretty much okay with that. I'll leave everything as it is default. Then I'm just going to create this table. So that's the first part of the challenge. Now the second part of the task will be to, whilst this is trying to do its creating stuff, we'll go back to our slide. It's to create a Lambda function. So let's go over to Lambda right here. This is Lambda. Now to create a Lambda function, we will use the same name, but we'll call this ending with function. We'll just need to create function. Pretty much easy, right? Clicking. Oh, it's all from the console. That's how easy it is to do stuff. Okay, great. Now we can author from scratch. We can use a blueprint or container image. They've got a bunch of options. I think I'm going to author from scratch because I'll have to build the JS file for this. Okay, so the function name, we'll give it a name. We'll just call this same HTTP. We'll call this create, read, use, delete. Then we'll call this function. That sounds like a good name again. Now under permissions, we can either choose defaults or we can maybe use execution role, but I'm going to stick with Node.js 14, or maybe I may go a bit backward a bit, 12. Yeah, I'll just use 12. The architecture, we would stick to x86, x64. Under permissions, we have the options to create a new role with basic Lambda permission, or we can carry out, maybe use an existing role, or probably create a new role from AWS policy templates, which means we IAM and do that role stuff. Let's see if we can actually just do this right on the fly here. So for the role, what we're going to do is we're going to just create a new role from AWS templates. Again, we're going to call this a role that is unique to what we've been doing. HTTP root, creates, read, use, delete. Then we'll give this just ending with role. All right. Then for the policy templates, this is where we'll go granular. We'll look for simple microservice permission, which is what we want. Okay, this is the permission. We'll select that, and I think just that one, it's okay for us to do what we want to do. Now this policy grants the Lambda function permission to actually interact with DynamoDB. Again, you want to be sure you're selecting that. We can see right at the base DynamoDB. If not, there won't be an interaction. The Lambda function won't be able to carry out an action on the DynamoDB database. So once this is done, we have the option to do advanced. Just to be sure that was selected correctly. So we have the option to do advanced. We can see that we can do some VPC tagging, some other tags and other stuff, but code signing pretty much important if it's a prod environment. Okay, so we're just going to create this function at this base level. We are okay. Now we have a function which will have to populate with our data. There seems to be a network error. Check that out. Okay, so we have the Lambda function page open. Now remember, we had used a managed policy here, which is not obviously best practice. You want to create an IAM policy and grant the required permission to that IAM policy to be able to do what we want to do, because managed policy sometimes might be excessive permission. Okay, so what we're going to do is we're going to remove this and paste our index.js file in here. Then we'll run the stuff, test it, and see how it works. Okay, let's go party. Okay, so we have the Lambda function. Now quickly running through this, we can see where we have actually specified the table name. It must match with the
DynamoDB table, be sure it does match. If it doesn't, obviously you'll be thrown with lots of errors. Okay, when you start trying to execute stuff, again, review your code, best practice. We also can see clearly here, just keep my eyes a bit. Okay, great. ID. So remember when we created that table, we actually set that IDs. Okay, great. So I think we're good to go. We will just deploy this, then we'll wait for the next. After deploying, we'll try to test this right here in the browser. Okay, so we got successful deploy, so which means we're good to go. All right, we'll skip the test phase and we'll come back to it when we have the API gateway thing set up. So let's move on to the next part of the challenge or the task, which would be to create an HTTP API. So at this point, we're going to be using the API gateway. Right here, it's open in my browser, also to save us some time. Then we'll choose to create an API. Now we've got options. You can either use the HTTP API or the WebSocket, like I did mention, or even the REST, or even the REST API private. Each of these actually are different. So you want to go do a bit of research to understand which matches the application you're trying to build. So you're making the right decision, the right choice. So we're going for API, HTTP API. We'll just click on build. So we'll give this a name again that is unique, so we can actually use this to do whatever we'll be doing. Okay, be sure you pay detailed attention to the naming convention. Right here we have this HTTP CRUD function. Okay, so going back to this, we will try to create, we'll give this API a name. For this, we'll call this template HTTP CRUD. Then let's just call this API. All right, that's pretty much okay. We'll click on next. Now at this point, we have the option to configure routes. So again, it's very important that you understand how this stuff works. We can skip this and treat it in the next phase, but again, we can still do this right here. So we'll see if we can just skip this and do it in the next phase. Okay, so we will just skip the route. We'll create in the next phase. Now we've got stages, also very important. Stages, as you can see, are independently configurable environment that your API can be deployed to. So whilst the routes help you understand what kind of request you're receiving or action you're trying to carry out, the stages are also very critical to help you have that pre-configurable environment. We're going to just leave this as default or to deploy. Then we will go next, review whatever we have, and create the API. Okay, so once this is created, we'll move on to now create routes within that API. So let's go create some routes. Now we can see right here to my left, we've got deploy option, where we can create routes, authorization, integration, cross-origin reference, resource sharing, then also a bunch of export and other stuff, throttling as well. This, like I did mention from the start, it's quite flexible and dynamic enough to help you manage APIs. So we're going to click on routes. Then we will create the first route, which would be maybe the get route. So under here, we will search for method. Let's do get. Okay, I'm just going to click on create. Look for get as the first one. So the path has to match the items and the ID which we have actually on the table. So items, then we'll open this up. I hope that spelling is correct. Okay, then we'll open this up and put in the ID. Okay, that's all for the first route which we're creating. Now we'll create this route. Then we'll create routes also for other actions which we'll be carrying, which will be to delete, to put. So let's go ahead. We've done for get. Let's do for delete. We'll call this delete. Again, we'll repeat the same thing. It's going to be the same items. Then we go to the ID. We'll create this. Then also we'll create for puts. Maybe 3 is okay. Then we'll create for puts. We'll call this puts. We can do for post as well, for other actions as well. So items, then ID in here. All right, so that's it for the routes. Now we've got these 3 routes, so you can look at each of them. We can do a bit of authorization attachments if you want to, again, go granular, or we can do integration, which we'll be looking at later. Okay, for all 3 of them as well. We see they all fall under the ID, all under the items, also understanding the way that structure works. Okay, so let's go about with the integration. So for the integration, we will go over here and select integration and follow the walkthrough again. So what are we trying to integrate here? So we're going to choose integration, then manage integrations. We'll see about that. So from this point in time, we can actually attach integration to routes. So remember, we can either create this. If we create this, then we can set the integration that we want to select. Right here, we will see options. So what we'll be looking for is a Lambda function. We will go for the Lambda function. Then again, I will leave this within this default AWS region, which obviously pretty much okay for me. Then the Lambda function, we want to be sure it matches with our Lambda function, which is what we've defined as this. So I'm going to copy this and just paste this over here. I could probably find it there. Okay, that's it right there. I'm just going to select it. Okay, we can go advanced, do optional description, invoke permissions if necessary, but all the stuff I'm going to skip. This is basically just showing you at the bearable minimum level what you can do with this stuff. So I'm going to go ahead and create this stuff. Okay, so now we have our integration attached to all three routes which we've created. Pretty much we can detach these, we can manage integrations, but we have it attached to all three routes. So the next phase of this will be to attach our integration to route, which we've just done. Then after which we can now try to see if we can test our APIs and see if this whole stuff is going to work. So let's maybe get on the API gateway and choose the API to run the test, but we can use curl to do the same thing actually. Okay, so now let's go ahead with the test. To get the link for the API, we can fall back to API. We click on the API, which is this. We will see below there is the invoke URL. So I'm just going to copy this invoke URL. Then I'll be using curl to test this. So I'll open up my bash here. I'll use curl to run some standard test which I have as a template. Then we'll see if this stuff works. If it does work, you should be able to carry out actions. Okay, let me copy that test and paste it here. Oh, my bad. Okay, I'm gonna clear this. I will have to use Notepad. Okay, I'm just gonna pause this recording then. Okay, so we have the command to test this. I'll bring up my bash again and paste this right there and run this. Okay, well, we got not found. Okay, interesting. All right, we will check and understand why we can find this, then probably get back to the video. Okay, so I took a while to fix my Lambda function. Got quite a number of bugs, but I got it fixed now, and went back and ran a couple of tests. I'll just walk you quickly through those tests. So the first test you see here is I'm using curl to actually hit that API. Then we are trying to verify if there's a content like this. We can see all the verification TLS, and then at the final point we saw this fall 4. Obviously that's bad, but we'll come to that later. Then I repeated the same task. Now I'm specifying this is actually to simulate a bad request, seeing how API gateway will handle that. Then I came back to this running again. Now I'm specifying the items table which you've created, then looking out for these content on the item. Again, in this point we got 200 because obviously we have a table like that, but we do not have an item of such in there, so we deleted that item obviously. Then the next one we can see here is just using curl to hit the API gateway, verifying if that works. We got 404. Okay, because we cannot hit the roots directory, we have to go into the item table. Lambda function will not be able to understand how to go in there. Then again we repeated the same thing. Now we specify the items table, and we can see lambda function gracefully actually returned 200. Okay, then give us the items counts. Currently there is nothing in there. Then we try to put in stuffs in there using called puts. We can see the method that was in this puts. Then the header, the content type, we set that to application JSON to match our Lambda function. Then we now drop a bit of content, ID, price, name, item, and all this random stuff. Now we got 200 OK for this, and we've been able to put an item. Then we try to view the item again using curl, and right here we can see the item. Great, which is good enough at this point. Now we try to specify view a specific item in the table. Again, we were able to do that. We can see the item attributes. Then we use curl to delete. At this point we're removing the item, and again that's return 200 OK. We're able to delete the item, deleted the item. So these are all the tests which we've run. Now I'm going to show you something pretty cool, how we can use Cloudwatch to understand how these API gateway is actually behaving. Over here in my Cloudwatch, I can see there is an alarm being triggered, and the triggering is actually because I've actually consumed my read capacity and my write capacity. Okay, so we can see right here target table, which is this table. On the DynamoDB, we've consumed the read capacity unit less than 30% for 15 data points within 15 minutes. Now I can click into this to look into that log, that alarm, understand what exactly it is. Remember, we had configured Cloudwatch to actually give us visibility, so we can see how clearly we see the timeline within Cloudwatch where that issue actually happens. Now we've got the options to carry out specific details viewing, understanding exactly the description of that alert. Then we can carry out an action if we deem that fits. Auto scaling would be the better approach to go about this. Okay, but we didn't set none of such. Then we can as well view history just to see the successful requests which we're pulling through the API, and we got success execution. Okay, then also we can fall into the log groups. Obviously we created the log group to help us manage this whilst we were creating that API gateway. So we're going to look at this. It takes a while to load, and this will be the final thing I want to showcase tonight. So we can see right there we've got the HTTP group function, the Lambda function. We can just look at it, understand if there is any criticality, a way to have that visibility monitoring, and also understanding how your application is behaving. So we can see the start point for the function and the endpoint. Now I could use a much better tool like Artifact maybe to understand clearly if I want to have clear visibility. I would rather fall back to that to use as a way to have actionable results. But just to show you how Cloudwatch can be used to create that monitoring and alerting, as well as what your regular SIM will do in your on-prem environment. Okay, that will be it for this recording. Thank you for your patience, your time, and I hope you love the content. If you do, please do like and subscribe, and then turn on the notification button so you can receive the notice whenever we make good content like this out there for you guys. Have a good evening, and bye.